everyone, we are finally at the end of the activity 35 notes. We have 35.3 here. Before we get started with the last of the notes talking about area of actually triangles and other figures, let's review a little bit with the bell ringer here, how to find a point that's being rotated clockwise around the origin, as well as setting up a matrix multiplication to show a vertical stretch. Okay, so take a moment and answer those. Now, just to go over these real quick, reminder, you have the matrix for a clockwise location is cos theta, sine theta, negative sine theta, cos theta. If this had been counterclockwise, that just would have been the same setup, but with negative 30 plugged in. And we need to multiply that by 2, 4, so that we would end up with a point at 3.73-ish, 2.46. Right, that would be the location of that point. And then our setup for number 2, just to, again, to review, if you're going to stretch vertically only, the horizontal component is just going to be multiplied by 1, and the 4 would be our vertical component, and then multiplied by a 2 by 3 matrix with each of those x and y values plugged in, x in row 1, y's in row 2. So that would be their setup there. Okay. Now today we're kind of shifting gears a little bit, and we're going to talk about some real world situations by finding areas using determinants of our matrices. So it's been a little while since we talked about matrix. Now notice the triangle that is given in number 1 on page 509 in your book is located, it's got 3 points here, and one of those points is at the vertex 0, 0. This is an extremely important point today because in order to do these problems, our triangles must have a vertex at the origin at 0, 0. Right? Otherwise, we cannot solve these problems using a determinant. Why? Well, reminder, our determinants are only going to be found in square matrices. So we need a 2 by 2. And what can happen here is if our points are at 0, 0 and then 2 other points, we can just kind of ignore the 0, 0 and use these other 2 points instead. And the basic setup here, notice we have B is at RS, A is at TU. The basic setup we're going to use is finding 1/2 the absolute value of the determinant of the setup of these points. So R, S, T, and U. And again, it's the absolute value of that because area is a positive number. Or you could set it up officially as the absolute value. Instead of doing columns, we could say R, comma, S, T, comma, U. Honestly, though, just for consistency's sake, I say we go with this first one just to be careful there. And again, reminder, when we are finding the determinant, it's A times B minus A times D minus B times C. So that would look like R U times U minus S times T. And again, absolute value, it's always a positive number, our final answer. Okay, because we're going to be talking about areas. And that might be something you want to note to yourself as well, that area is always positive. So need absolute value of the determinant. Okay. Now, looking at this then in application, if we turn the page to page 510, we're going to see right here 2 basically lots that they're trying to put together to find the total square footage of lot 1 and lot 2. So for number 1, we are going to calculate the half the value of the determinant. Now notice for both of these triangles, one of the vertexes at the origin, so that's good news for us. So we want the half the determinant value of, if we're going for lot 1, 300 over 0, and 300 1 Now, reminder then, when we take A times D, 300 times 100 is 30,000. And then 300 times 0, well, anything times 0 is 0. So half of 30,000 means lot 1 square footage is 15,000 square feet. And for number 2, lot 2, again, 1/2 the determinant. This time we are going to use point A again, 300, 100. And then if we scroll up just so those of you can see if you're done with your book, B is at 400, 400. So 400, 400. So 1/2 of 300 times 400, which is 120,000, minus 400 times 100, which is 40,000. So half of 80,000 is 40,000 square feet. For a total area, out of room here, scroll a little bit, oops, too much there. Total area then, if we add those two together, 15,000 plus 40,000, we have 55,000 square feet of land. Okay. So if we look then at the check your understanding, take a moment to try A and B on your own. We'll skip C just for time's sake, but again, take a moment to check those out and find your final answer. Now, one thing to remember as you check these for 4A and 4B, your final answers, even if you came out with a negative number, you need to make sure you turn it into a positive answer because, again, we're talking about area, and area is always going to be considered a positive value, can't have negative square footage. So these should be your two answers for A and B. And we got those correct. And now moving on from there. If we skip through 6, we're going to skip over that and look at 7 on page 511. Notice right now we don't have these points currently with one at the origin. Okay, not everything is going to have something at the origin. So let's say, just for the sake of an example, this is at 1, 4. B is at 5, 6. 4, 6. And C is at, or excuse me, A down here is at 3, 1. What we can do to make this problem actually solvable in order to find the area is we can move one of these points so that the vertex is at the origin. So for example, if we move point A to 0, 0, if we shifted this whole thing over so that A was now at 0, 0, well, we had to subtract 3 units from our x values and subtract 1 unit from our y values. So if we do that same thing over here, subtract 3 and subtract 1, we'd be at negative 2, 3. And then over here, we would have shifted this again 3 left and 1 down. We would be at 2, 5. Now we can find the area of this triangle using 1/2 the absolute value of the determinant. So again, when in doubt, if it's not at the origin, move a point to the origin. And again, it does not matter which one you move, but let's say we would have moved C instead, then we would make sure we would subtract 1 and subtract 4 because from each of the other 2 points if we moved that. Or if we moved 5, 6, we would subtract 5 and then subtract 6 from the other 2 points. Again, it doesn't matter though which one you move. Now, last but not least, number 8, okay? What we need to do here is if we are trying to find any shaped polygon, how can we use it to help us determine the total area for a plot of land. So let's say we have, for instance, a pentagon. Let's just draw this pentagon here. Well, especially if one of your vertices is at 0, 0. So for instance, let's say this one's at 0, 0. We can now just divide these into 3 triangles, find the area of each of the triangles, and then add them all together to get the area of our figure. So especially for oblique shaped triangles or polygons in general, this is really nice to be able to find the area of each of these triangles and then just add them all together to find the total area using 1/2 the determinant. Okay. Now, your practice on this is actually on a worksheet. So you're going to complete that practice. You're going to check it with the key. And then finally, you will kind of take a mini quiz, quick check over all of activity 35, including this lesson. Thanks, everyone.